broadcast about DNA fingerprinting, which has become the new biggest thing in police crime investigations. Dr. Alex Jeffries from Great Britain accidentally found this process by using DNA and fingerprinting, and we'll show you the process later, basically. But he was able to do this, and now people can be exonerated, or they can be guilty based off of their own fingerprints that they left at the crime scene. This is huge, and it is remarkable about how many innocent people will now be exonerated from whatever crime that they had to confess to or were forced into. This can even help minorities and even other people who can't afford a lawyer by giving them solid evidence that they were not at the scene of the crime. So let's get into how we make it. Hello, and we're back today at the lab. So what we're going to be doing today is we're going to do an example of how Dr. Alex Jeffries DNA fingerprinted accidentally. He was actually trying to find inherited illnesses and how they're passed on from generation to generation. But instead, he found this very useful method that is used to help make people innocent or guilty. So first, we have our cell. This is not drawn to scale at all. So now we're going to cut the cell open. And now that we have our cell open, we're going to open it up and get our DNA strand. So here's our DNA strand with the strand AGGTA. So now what we're going to do is we're going to put that aside for later. We're going to get a radioactive probe. Thank you. Here's a radioactive probe to test to see if the DNA is similar. This one has ATCCGAT, but the way that DNA works is that it's opposites that are the same. So what this probe does is the A correlates to the T, which is the opposite, so it matches up. And same with A and T are together, and then C and G are together. So once we have that, we're going to get a piece of film, 80s version, which we have right here, and we're going to just stick it on like this. We're going to use some tape. And then we're going to stick one part on, and then we're going to stick the other one correlating to exactly where its coordinates are. So here's the T and the A and the G. So now we're going to get our developing tank right here, and we're going to put it in here. Now we're going to let that sit.
3 days later.
Welcome back. So we are back and we have our developing tank, and now our DNA is ready to be tested. Obviously it's been 3 days later, but there are no blurred lines as there should. And a barcode should emerge. We'll just pretend that there's a barcode emerging. And after that, you can see that that is that specific person's barcode. And so then now you can use that to compare to other DNA samples. Thank you. Okay, as you can see, DNA fingerprinting is very accurate, and it is also so cool because DNA actually stays in the cells even after it's out of your body. Even if the cell is dead, DNA will still be there.
And that's it for DNA fingerprinting for today's broadcast. But make sure to stay updated with daily cases about it.